Hello viewers, in this video lecture we are going to discuss the sulfonation reaction. This reaction also proceed by aromatic electrophilic substitution reaction mechanism, and this reaction plays very important role in the organic synthesis many reactions. Now we see how the sulfonation reaction takes place. The benzene react with a fuming sulfuric acid and gives a benzene sulfonic acid. The SO3H is called as sulfonic acid group. This is substituted on benzene, so this is a benzene sulfonic acid. Okay. Now, what is fuming sulfuric acid? The fuming sulfuric acid means a mixture of a sulfur trioxide and H₂SO₄. Now, let us see the reaction mechanism. As we know, in any aromatic electrophilic substitution reaction, the aromatic system will react with the electrophile. That electrophile may be a full-fledged positive charge like we discussed in the nitration reaction, or maybe induced dipole, that is in the halogenation reaction we discussed, or positive end of the dipole. Okay. Here the sulfur trioxide is a powerful electrophile, and that is the positive end of the electrophile. Okay, it is having one positive end electrophile of the dipole. Here in the sulfur trioxide, the sulfur is connected to 3 oxygen atoms. As we know, the oxygen is highly electronegative than sulfur. Okay, so that means the oxygen will withdraw the electrons. So as a result, the sulfur will be partially positive charge and this will be partially negative charge. Okay, as a result, the sulfur is here a positive end of the dipole, and this one will attack the benzene. Pi electrons will attack the positive charge of the sulfur, and we will get this intermediate. Okay, so like this we will get it, that uranium ion complex. So like this it formed, and here this carbon atom of the benzene will get positive charge. Now this will restore the aromaticity by losing this proton, and we get like this. Sulfonate ion, and this will get a protonated from this. Okay, finally we will get a benzene sulfonic acid. Okay, like this. So this is benzene sulfonic acid. So this reaction is highly reversible. Okay, due to this reversible reaction of this sulfonation, this method has been highly employed as a blocking group. The sulfonic acid is acting as a blocking group in certain position of the benzene carbon. Okay, that we will see the utility in forthcoming classes. Now I will show you how the reversibility of the sulfonation reaction takes place. That I will explain its mechanism. So this is our benzene sulfonic acid. Okay, now this you are reheating the benzene sulfonic acid in the presence of this catalytic amount of sulfuric acid, water, and you are heating it. So then you will get the benzene plus sulfur trioxide. This you will get back. Now we see the mechanism, how this reversible reaction will take place. So this is your sulfonic acid, and it is taking a proton from that sulfuric acid and it forms like this. So this will get protonated at the carbon where the sulfonic acid group is attached, because that is highly electron withdrawing group. So there it will get protonated. Okay, and this will get like this. Okay, and this we get the positive charge. Now what is going to happen is, upon heating this, whatever the bond between this hydrogen and oxygen, so like this will get a break and this will move like this. Finally you will get like this. Okay, so this is how the reversible of sulfonation takes place. Okay, that's all. So this is the sulfonation reaction and how the reversibility of benzene sulfonic acid to a benzene. I hope you understand this reaction, and this is very useful in so many organic synthesis that we will discuss in the forthcoming classes. Thank you.